So let me express the problem, and then we'll pick problem. So when you read the problem, you have to read it very carefully, maybe more than once. When you come to a point where it says when, at the moment, at the instant, this is a trap. And it's very easy to fall into this trap or a problem. So what am I saying here? These have to come into or used in the problem at the last step. So find the rate of change of blah, blah, blah when, or find the rate of change at the moment, blah, 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 or find it at the instant. Always leave these at the very end. Do not include them in the problem till you are completely done with everything. Okay? So we're going to always look for this trap, so not to fall into it. Okay, so let's start with number 4, only because I started with that example, so let's finish that up. Okay, so I think I'm on page 12. Yes, on page 12. Good. So the radius of a sphere is increasing at a rate of 4 millimeters per second. So this is problem 4, and we have 4 millimeters per second. I have to stop. There is a full stop, and I need to understand what this is. Let's read it one more time. If I cannot identify this, I cannot continue. So I won't be able to continue. So the radius of a sphere, the radius is increasing at a rate of 4 millimeters per second. So to be exact, I should also put a positive in front. There is no need, but I'm just emphasizing. It's increasing at the rate of 4 millimeters per second. What does this represent? So let's say the radius is denoted by r. What is given here? What is this?
Is it the derivative of r?
Yes, indeed. It's dr over dt. How do I know? Thank you so much. Because this is measured in millimeters and this is measured in seconds. And this is carved in stone. It has 2 measurement units. It has to be a derivative. Awesome. Thank you so much. Then we can read on. How fast is the volume of the sphere increasing when? That's the trap. That's the trap. We got to the point, or the word when the diameter is 80 millimeters. Diameter 80 millimeters. We're asked to find how fast is the volume increasing. So this is a trap. I'm not going to even consider it. What am I asked to find? When the diameter is 80 millimeters. What am I asked to find? It says find how fast is the volume changing when, and I don't even care when. How fast is
that acceleration?
How do I write? How fast is the volume changing?
dV over dt?
Exactly. That's all I needed. Thank you so much. That's what I'm asked. But this cannot be considered to the last step of the problem. Don't even look at it. So I start with the volume, which is 4 pi over 3 r cubed. We already did this a few minutes ago. You already told me dv over dt equals 4 pi r squared dr over dt. And I have everything I need. Now I can say when the diameter is 80, but I need the radius, which means when the radius is how much? If the diameter is 80 millimeters, how much is the radius?
40.
Very good. So then I can continue here, and I have 4 pi. I have the radius squared, which is 16 with 2 zeros, times dr over dt that is given to me as 4. And it's done. I need an approximation for something like this. So 4 times pi, I didn't take the 4. 4 times pi times 1600 times 1600 and times 4. I got 80424.77. Without the measurement unit, it doesn't mean much. I need the measurement unit. We're talking about dv over dt. What will be the measurement unit for dv over dt?
Millimeters per second squared.
dv over
Wow.
dv is
Millimeters squared or cubed.
exactly over dt.
Per second.
That's it. That is it. So that was a simple example as a warm-up. Let's continue with others. Okay. A cylindrical tank with a radius of 5 meters that is carved in stone, that does not appear after is being filled with water at a rate of this. How fast is the height of the water increasing? So in this case, there is not even the word when. It means it will be probably a constant because it doesn't say when or at the instant or at the moment. So let's take a look at that. Number 7. So in 7, we have a cylindrical tank. So I'm going to draw a cylinder, okay, with a radius of 5. So there is no discussion. Radius is 5 meters. It's being filled with water at a rate of 3 cubic meters per minute. I have to stop. I don't even read on. I have to identify what this is. That's my first step. I need to clearly specify this. Based on the measurement unit, I know exactly what it is.
Is it dv over
Differentiation of the
dt?
volume.
Yes, dv over dt. Awesome. Now I can read on. Okay, so how fast is the height of the water increasing? So we are expecting a positive answer, increasing. So this is the height. What are we asked to determine? How fast is the height of the water increasing? How fast is the rate of the water increasing? So it's a rate of change. How fast is the rate of the water, of the height of the water increasing?
Is that the 3?
This is the volume.
Oh, sorry.
How fast is the height of the water increasing? We know how fast is the volume increasing.
Mm-hmm.
We want to determine how fast is the height increasing. What do you think?
So dH
Over,
over dt.
of course, that's exactly it. So we want a volume, we have to start with the volume of a cylinder. It's the area of the base times the height. So the volume for a cylinder is area of the base pi r squared times the height. R is fixed, it doesn't change, so I have 25 pi h. And now I have to differentiate. So let's do that. Page 13. Good. So dV over dt equals 25 pi. So this is a function of time, and this is a function of time. Can anyone differentiate h? So I can put it here.
dH over dt.
That's it. Because there is no power, there is nothing else. dH over dt. So in order to solve for this, all I have to do is divide both sides by 25 pi. So dH over dt equals, do not separate these two. This is one variable, goes to the top, as we know, divided by 25 pi. So this is 3, and this is 25 pi. I'm going to approximate it. Careful how you enter it. 3 divided by parentheses, 25 pi. And close. So I got 0.0382 measurement unit. And we know exactly what the measurement unit is.
Is that meters or meters per second
Per minute.
or
Yeah,
minute?
that's it. Meters per minute. Any questions so far? Any questions? Not too bad so far. You answered all my questions. Let me see. So this is scratch paper. I don't want to write on this. I have my paper right here. I need, sorry for the delay. I need more paper. I have the scratch paper just in case for questions during the study groups. So, but I don't want to write the lesson on scratch paper. Okay, perfect. So let's continue. Okay. Are you interested in any of the part A or B in number 9, or we move on? Okay, no one said anything. Okay, 15. So let's look at 15. A street light is mounted at the top of a 15-foot tall pole. That's what I have so far. From each sentence, I learned something. A man 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. Okay. I cannot draw a person, I'm sorry. So he's walking away. This is the distance covered by him or her. Okay, doesn't matter. So this is the distance. And we're told A man 6 feet tall walks away from the pole with a speed of 5 feet per second. Okay, fine. I need to identify what is 5 feet per second.
That'd be dx over dt.
Absolutely, thank you so much. That's the speed of the person. And she covers from here on. And this is the distance covered already at this instant. So dx over dt is the 5 feet per second. Awesome, thank you so much. Good. How fast is the tip of his shadow moving when? That's the trap. I got to when. I cannot use anything after when till the last moment of the problem. How fast is the tip of his shadow moving when he is 40 feet from the pole? I'm going to write it, but I'm going to make myself a note. When 40 feet from A. Okay? But this is the when. I cannot touch it till the last moment. We're going to read the problem one more time. A streetlight is mounted at the top of a 15-foot tall pole. Got it. Somebody is 6 feet tall and walks away from the pole with a speed of 5 feet per second. Identified clearly. Along a straight path. That's fine. How fast is the tip of his shadow moving when the person is 40 feet from the pole? So, now when the person is here, see what happens? And this is a tip. So when the person is here, here's the tip of the shadow. When the person is here, here's the tip of the shadow. Okay. Any questions so far? Now, if you notice, there was one thing I didn't mention. So this is 6 feet. So we have the following scenario. We have 6 feet here, we have 15 here, and we have x here. And we have to also denote this by a letter. So I'm going to say this is y. Anyone remember something from a long time ago that connects this triangle to this triangle? Of course, they're not equal, or we say congruent. Of course, they're not. But they, yes?
Their angles are the same?
Yes,
right?
Yes. This angle is common in both. This angle is 90 degrees. So therefore, this angle and this angle have to be the same. No doubt about it. If two pairs are congruent, the third has to be the same. Good. But what does that mean? So what did I accomplish with that?
The triangles are similar.
Brilliant.
Therefore proportional.
Yes, the sides are proportional. Awesome. So it's called similar triangles. They are similar because we're able to show at least two pairs. Well, of course, it will be three, but at least two pairs of congruent angles. This is common to both. These are equal, therefore these two are equal. Because we showed that angles are congruent, then we can write proportions with their sides. Now I want you to be very careful how you write the proportions. So let me stop. I